Good afternoon, everyone.
Afternoon.
Hello, welcome to today's lecture. Hope you all are safe and healthy, and you know, so stay safe, huh? Right. So today is Monday, week 5. So the topic we cover today is continuation of the topic of ACL, right, which we started last week. Okay, so last week we looked at the theory behind ACL, or access control list, right? It's a way for you to filter traffic going in and out of your network, yeah, right? So this ACL is applied at the router. Okay, so that means we are able to do some filtering. So if you think about it, it works as very similar to firewalls, the concept of firewalls. Okay, so but here we are able to fine tune the filter based on range of IP address. Okay, based on single IP address or range of IP address on the whole network segment, right? So we look at the concept of ACL last week. So this week we continue that with the configuration part, right? So we know that ACL, we have numbered and named ACL, right? So we can look at both of them, and we're going to look at the commands that we can use to add, to edit, and also to remove ACLs, right? And we're going to look at extended as well, right? So standard ACL, numbered ACL is basically just filtering based on IP address, whereas in addition to that, for extended ACL, we are able to specify what protocols, okay, are involved in our filtering, right? Okay, so let's get started. So I'll start to record as well. I'm going to record our session. Right, so you can see the topic is ACL for IPv4 configuration. So we focus on IPv4, and we focus on the configuration that we need to do on our router. Let's go there. So let's have a look at briefly at the topics we're going to cover. You can see there configure standard IPv4 ACLs, right? So to filter traffic, okay, and this is based on the IPv4 addresses, right? And then we learn how to modify. Let's say you have a change in the filtering ACL, so we want to modify, maybe due to additional or change in the IP address range, or even typo, making mistakes, right? So we learn how to modify IPv4 ACLs, and we want to secure terminal access, VTY access. So we're going to use standard ACL, see whether we can secure, because you know that terminal is used to remotely take over a computer. So this is very, very important that we allow only certain authorized, end devices or hosts to be able to do this access, VTY access. Right, so VTY access, we'll see that this terminal access, we want to filter so that we can secure, right? Secure how we want, or which host we want to be able to access. Okay, so basically filtering the traffic of VTY effectively prohibits, um, unauthorized hosts to access, to have access to a certain um, IP address or range of IP address. Okay, so to secure VTY access. And then we look at extended IPv4 ACLs, right? Again, to filter traffic, but now for extended IPv4 ACLs, we can actually say what protocol, okay, or which protocol that we want to filter, right? Okay, so we can filter incoming or outgoing traffic. Okay, so let's have a look at configuring standard IPv4 ACL first. Right, so to configure, right, we don't simply uh, go inside our router and start entering ACLs. We have to plan. Okay, so we have to plan the purpose of the ACL. What are we going to filter out, and from where, or which host, or which IP address, or which network segment, right? So because prior to this, we are allowing any traffic as long as it's routable through our router. We allow, okay, we allow the traffic to proceed. We forward the traffic, but now we want to filter, right? And sometimes, depending on our organization's network, right? We might have just one single LAN, so that's easier for us to configure. But sometimes we have multiple LANs, right? And this work also on virtual LANs, right? So when we have a large network, right, and then we have different, the policy for different traffic, for different hosts, different network, then it can quickly become very complex, this ACL, right? So as I mentioned earlier on, I want to again mention again, right? This is actually a technique. Okay, this technique allow you to simplify the design and implementation of complex ACL, right? To also to reduce typo errors, right? And to have a overall view of your ACL design before you commit to entering the ACL into the router. So the thing is, it's easier to enter correctly by planning carefully rather than going in, making a mistake, and then having to change it again, right? So the tools you need, very simple, right? Normal text editor. The thing is, iOS commands are also normal text, yeah. So which means you can copy, right? Once you have all the ACL lists for a specific router, right, and for a specific interface on the router, then you can simply copy paste, right? Of course, you can't really test until you enter, but what you can do is do a walkthrough through the ACL list, right? And work out whether the filtering is correct or not. Okay, so basically very similar to when you're writing a program codes and you do a manual walkthrough through your codes. Yeah. All right. So use any text editor. Okay, I'm not sure if there's any editor that is specifically geared for SELs, because what I mean by specifically geared for SEL means it has syntax highlighting. It will help because it will highlight the specific part of the ACL. But if not, then a normal text editor, even a notepad editor, is sufficient. Yeah. So there you can list out or type in the text editor all the SELs, okay, that match the policy. Remember, the ACL is to be entered at the interface for a particular router. So it all depends on the policy, your organizational policy. So to start with, make sure you get the organizational policy for what is needs to be filtered, what's allowed, what's not allowed, right? So once you get that, convert that into ACL commands. Okay, type out your ACLs command inside text editor and manually go through to debug it, to find out if and to remove any typo, right? Right. So once that, in order for you to be able to document it, because ACL, it's very hard to just look at the command and understand immediately, because sometimes the output of the filter is due to combination of several ACL statement. So several ACL filters working together will produce, it's just imagine like a Venn diagram, right? So we'll produce the filtering behavior. So include remarks as a way to document, right? So that you can recall meaningful comments, right? So that you can, by looking at the remarks, you don't have to look at the ACL commands. By looking at the remarks, you know what's the purpose of that particular ACL line or lines, right? So once you're confident that your ACL commands are all correct, right, and it does what you need to implement, the policy that you need to be implemented, then you can just simply copy and paste the command into the iOS command line interface, right? This works whether you're using packet tracer or you're using terminal to access or console to access the real hardware. Okay, at any time you basically you're using a terminal software in any case to access your device, your router, so you can do copy and paste, right? Make sure once you do that, once it's entered, do a thorough test. Go back to you must also, if it's convenient, per policy, right? Per policy here, you should test the policy. If your ACL mirrors the policy, then basically when you do a test on the ACL result, okay, will mirror the policy. Okay, so this is the best way to do it systematically. All right, so let's have a look at numbered standard IPv4 ACL syntax. So the syntax is very simple, right? The command for ACL is access list, and you can provide the number. Standard ACL is you basically use access list number. Then you need to know based on the policy whether it's to deny or permit, right? The remark here is what I mentioned earlier on, is a way for you to comment, provide comment. Now that one will not be executed, it's just a way to provide comment, right, for that particular access list, right? It's a way for you to have an online documentation on the access list itself, right? And then after that, so the pipe character here symbolize that it's an or. It's either deny or permit, or it's a remark with the text, the comment, right? And then you can provide a source. So you can see for numbered standard SCL. Standard SCL works on source IP address. And the source wildcard is a way to filter based on the IP address. You can get the subnet mask, and from the subnet mask, you can then calculate the source wildcard. The source wildcard, depending on the wildcard that you put in, whether permit or deny. So it means this source and source wildcard, if you recall from our previous lecture, is a way to match, right? To match any traffic, because traffic will contain on the header, on the packet header, you contain the destination and the source IP address. So here we are going to match source, right? So the source in combination of the wildcard will provide the filtering. Okay, what we want is when it match, if any traffic, incoming traffic with the source IP address that match our filter here, this is actually the one that's doing filter, and then it will apply our policy, whether we deny the match packet or we permit the match packet. The packet will be represented by the packet source IP address. All right. Okay, so here are the parameters here as described. Right. Okay, the log part is optional as well. The log part basically just send information message for your consumption, right? When the access control entry is matched. So access list is a list of access control entries. Each entry is called an ACE, right? Just to remind you again with the definition, right? To remove, once you enter, if you discover you make a typo or mistake, or for whatever reason you want to remove that access list, put a no in front. As typical in a Cisco iOS, if to remove a command, then you have to put no in front. So just copy back So that's why here it's very good to have a copy of it in a text editor. You save that text, yeah. So you basically have that command ready. So if to to prevent any typo while amending or removing, so you just copy put a note in front of the command, the ACL entry, and then type it out. So just put no and the exact ace, and then it will be remove. Okay, no is to delete that particular entry. Right? Okay. Right. So to create a name standard ACL, use the IP address list standard command. So we basically want to have use the names, right? Contrast that with numbered access list number name. You have the access list name. Okay, slightly different, right? You say IP access list standard, then access list name. So it's more meaningful, right? Compared to number, right? So ACL names, this one, alphanumeric, case sensitive, and must be unique. So again, by putting it inside your text editor first, you can visually see before you commit, okay, whether your ACL names are correct or not, right? Capitalizing ACL names is not required, so it's not part of the syntax, but for better viewing, better, faster understanding of the access list or ACE, then it does stand out if you capitalize ACL names, right? Right. So this is the syntax, and this is example. So let's say IP access list standard, no access. So we name it no access, right? And then it will go to config standard NACL, right? And then question mark inside here, simply hang on. Right. So providing question mark here is as before, will provide a list of available commands that you can set while inside this configuration, right? So you can see default, deny, exit, no, permit, remark. Okay, as before, we focus on deny, permit, and remark as the options. Right. To apply standard IPv4 ACL, once it's configured, it must be linked to an interface or feature. The IP access group command, okay? No more access list, no more access list. Access group command is used to bind, whether you create a number or name, you can bind them to the access group, okay? Which is bound to an interface, right? So command syntax is IP access group, access list number, or access list name, whichever you use, in or out. That means incoming or outbound, inbound or outbound. To remove this access group command, then put no, right? Put no in front. Okay. So how do you select the interface? By using in global config, you just type the interface that you want to configure it on, right? So interface, and then what's the interface? G0/1 for gigabit 1 interface. Then it will go into config interface. Then for that particular interface, you can then type this. So where you're filtering inbound traffic or outbound traffic, right? All right. At any time, please alert me if you have any questions. Alert me by doing this, right? And ask your question or type your question. Okay.
Okay.
Right.
Okay.
Right. So here is a topology that we're going to use, a simple topology that we're going to use to demonstrate how to configure and apply numbered and named standard IPv4 ACLs to the interface. So let's have a look. we have three interfaces here. So the serial interface and 2 gigabit interface, gigabit 0, gigabit 1, and serial 0, right? Serial 0 is the one that is facing the public, the interface, the internet, right? So each of the gigabit goes to interface goes to our two LANs. Okay, we can assume that these two LANs are our, our organization's current network. Yeah, one given this network address, and the other one with this network address. Okay, right. So in this is our topology lah. This is our topology. Of course, we simplify it a lot, right? Most large organizations will have a very more complex topology. Right. So we have one router, and we only apply ACL on routers, not on switches. Okay. So on the router, we have the host name for router is R1, right? So this is our policy. Perhaps the example ACL permits traffic from host 192.168.10.10. You notice here 10.10, right? And all hosts on the 192.168.20 dot zero network, right? So specific PC1, okay, host, 10.10 host, our policy host permit the traffic of from this host, and the whole segment, network segment here, not network address means every host within that resides within this network. So you can see here, all hosts on the 192.168.20.0 or 20.0 here. So all hosts within LAN 2 versus one host dot 10.10 in LAN 1. Okay, from host, all hosts. Okay, out network out interface serial on router R1. So if you look at the serial interfaces here, out, okay, outbound, right? Allow outbound from this PC and all hosts here to the internet. Okay, so this is our policy. So how do we implement it? So we go to R1, we create, right? We create ACL first. So ACL list, this is numbered, so we just put arbitrary number 10, okay, and then we put a remark. Okay, ACE permits only hosts. We want to do this policy, the first policy here. So this is our comment permits only hosts with this IP address to the internet. Why internet? Because this serial port here, serial interface here is connected directly to internet, right? So what we do is access list 10 permit host 192.168.10.10. This is host. Notice that with the host there, single address. So there's no need to have the wildcard. The wildcard is when you want to provide a range, right? So without a range, it's a particular host. Then we don't need to we don't put the the wildcard is okay. But if you want to put a wildcard, also can. But make sure you restrict to this. That means 255, 255, 255, 255. Exactly match. Remember, one is, I think, hang on. One is, I told the 0, 0, 0, 0. 0 is exactly match. One is not match, right? So that means you can drop the wildcard part optional if you specify a host, right? So that's it, basically. Access list 10 permit this host on that particular. Later we'll put this access list into the serial interface. Okay, for now we create the access list first. So we have ACE in this access list 10. we have an ACE that says permit 192.168.10.10 traffic. Okay, then we want to do this one. This is the whole, it's a range, right? Not host anymore. So again, we provide the remark, access list 10 permit that network address and exactly match 192.168.20, but any value in the fourth octet. So 11111 match any value. So the wildcard is 00255255. Sorry, 255. As you can see, when you show access list, you have additional ACE now. 20 permit this one. Wildcard bits 000255. Then we want to apply it, right? Want to apply it. Notice that I use the same numbers, right? Because these two apply in the same interface, so I just group them, right? So that means they're part of the same group because of the access list number, right? So now to apply, I created access list. I want to apply it on the interface. So I select my interface. So from global config, I call out interface serial 0, right? Which is that interface, right? And then IP access group 10 out. 10 being the access list number, right? And out means this one, outgoing traffic, right? So then I've applied exactly based on the policy here, right? Any question here? This one is okay or not so far?
So the remark acts as a description.
Yes, the remark is basically a description. It's like in a programming code, I put comment. So easier for you to have a look, right? To basically, I think it's under different command. Access to show access list will just show you the access list, but I think another command will show you including the remark. So rather than having to, because you see, if you have a lot of S entry, access control entry, right? In order to understand each of the entry, you have to basically work it out in your mind. Oh, what's access list, then permit host 1 and 2, okay, permit. By simply having remark here, you can ignore that and then just read, oh, this ACE is to permit only, okay. This one permit, oh, okay. It makes more sense, okay, when you write it out in terms of meaningful comments. So remarks is quite important as a way to document, right? Document your ACE.
Okay.
So yes, under show running config, if you view using show running config, you will see the remark. Right, so here you just want to see the access list, and it just show you access list entry itself. But if you want to see the including the comment, then you show run, and then filter, so you don't see any other things. Show run, filter, section, access list. Then it shows you including the remark. So rather than trying to understand this part, you just read the comments, the remarks, then you understand what is the entry for. Okay. So it's very exactly like the use of comments in your programming code. When you're coding, right? You put in comments so that later on when you come back to look at your codes, you don't have to, stress out to understand the code. You just read the comments and then you, oh, okay. So this is what this part is for, right? Right. So to see whether it is filtering outgoing or ingoing, you do this show IP interface serial include. Again, this is a filtering include access list. So you can see for this serial interface, which access list is applied to it, and for incoming or outgoing traffic. So you can see here this command, you can straight away see, oh, right, there is an outgoing access list that is 10. So knowing this, then you can check, right? That means this is basically like a high level viewpoint lah. For this for this interface, what access list is applied? Oh, outgoing access list 10. Then you can go here, show run, and then you can see for 10, what are the outgoing permission, right? Why we would permit? Because just remember, even though you type here permit, there is an implicit deny. So apart from this permit, all other traffic will be denied, right? So this permit, then implicit deny on all traffic. So, and all addresses, other addresses. So that means after this permit, it will deny any other traffic. So that means only these two are permitted to go to the internet, either this host or all hosts in LAN 2. Right? Is it okay so far?
Okay.
Okay. All right. So now, now we look numbered, right? Let's look at name. Right. So this is an alternate way. You can either use numbered or you can use name standard ACL. Again, I think we are using the same policy. You can see example ACL permits traffic for this host and all hosts on this network out of the 0, 0, okay, on the router 1. Okay, so we remove what we have done here, the numbered. So to remove, simply all the A's belonging to access list 10, just put no access list 10. And both of this permission you set up will be removed. So we can start fresh. Okay. Right. So we create the access list standard with the name permit access. Right. And then we say, then it goes here, then allow us to enter the right? So here you see, because we don't use the numbering, numbering, you have to type access list what number. Here no need because we are name. So once you put in the name, right, permit access, it goes into config standard, right? ACL or name ACL, and ACL is name ACL. So as before, we want to comment. So we remark is this access control entry permits this host. We assume because we are doing it here, right? Then it's belong to permit access. So permit host, again host, there's no need wildcard, right? Then the next case is we want to comment also remark as permit now is for sorry, that's the one already. The second case is remark as permit all hosts in LAN 2. Then again permit, and then our filter, our range, and then exit, and then go to similar, go to interface 0, 0. Then at IP, now we provide the group name, IP access group permit access out, then N. So it's quite similar, but slightly different because now instead of working with number, we're working with name, right? Make sure there's no space between your names. If you want to provide like permit access, put a dash in between, okay? Right? Remember, do not use blank space, okay? Right, again, so for verifying what we have entered, you can do show access list, right? And it shows in the IP access list permit access and the two A's that we have entered. Or you can type show run section IP access list and it shows you basically the same thing. And then if you want to see outgoing and the access list, right? Then you can see outgoing access list permit access by doing this command. Right, when you see permit access, then you can do show run section IP access list. Shows you the two A's for that particular name ACL. Right. Okay, so if no question over here, let's move on to the next, which is to modify the IP version 4 ACLs. Right. Two methods to modify an ACL. Okay. So why we want to modify it? Sometimes as due to, but most times due to mistakes, right? Due to mistakes. We make a mistake, a typo, right? And that's all we need to modify the ACL. Is it typo or logically assigning a different ACL for a particular, you know? So we make a mistake, right? So if you are dealing with ACLs with multiple entries inside, okay, usually it's correct because it's a combination. You see, the outcome of that ACL is usually a combination of all the permission or deny inside the ACE. Okay, each ACE contributes to that, right? So sometimes it's quite difficult to configure, right? Right? So maybe you thought you walk through, you thought the ACL or the ACE you put in for that ACLs should be working fine, but then when you test it, it doesn't work as, and then that means logically you made a mistake, logical mistake. So you want to modify, right? So there are two ways. You can use a text editor as usual. You type out the no part. You take the save ACE last time you save, right, in the text editor, right? And then you just put no in front, it will remove it, and then you can then enter the correct ACEs or access list. Or you can use sequence number. Sequence number, we'll see. So let's look at text editor method first, right? So as I mentioned before, you have to remove before you can put in the new ACL. To remove ACL, this is the way. Remove the ACL, the wrong ACL, right, and paste in the correct ACL. Okay. Right, to remove, just simply put no. So if we are using, if we're going to delete the entire list, right, it's much easier lah, because you save it inside your notepad, right? Not text editor. Sorry. You basically you have all the lists. So why not? Because it's numbered, all belong to one. To save time, instead of put no access, right? No access is one, and then put in. Just make your correction for the whole list, all the S entry. That's fine. Just delete the entire access list first. No access list one means all these two will be deleted. Then you copy paste the correct one, then it will recreate it for you. So it's like this is quite fast, right? Quite fast. So this I kind of like this text editor method, right? The other option is to use the sequence number method. Sequence number method, when you say when you put in show access list, it shows you with sequence. Yeah, both of these are belong to list one, right? Access list one, but you can see 10. This is that means this is the one in front, 10, and then the 20. You want to add if you want to insert, you can insert here. Okay, but here is just want to modify, right? So 10, 20. That is our sequence number, right? To know the sequence number, just show access list. Then you can see first one is 10 sequence number, second one is 20 sequence number. Doesn't really mean anything. It's 10 and 20. Yeah, it's just sequence number given, right? So let's say you only want to modify that one. You don't want to do this way, right? You want to, I just want to, modify 10, right? So what you want to do is you delete 10, right? This is sequence number. Okay. So no 10, you will delete it. Then you re-enter 10, then deny host instead of permit. deny, right? Oh, it's already denied. Then deny host, and then the host address, then it will replace the previous one, right? It will replace, of course, here we just recreate. Oh, sorry, this is 19 typo, right? 19. So it's actually it should be 192. So you want to remove this, edit this to become 192. So now 10 deletes that, 20 remains. But since you know it's 10, then you just type 10 in front of the sequence number, then type in the correct ACE, deny host 192 instead of 19, right? And then you can see after that, it will update the access control entry to the correct one, to the latest one, right?
So by default, it's 10, 20, 30.
Yes, this one you don't it's not entered by you. This one is given by the Cisco iOS,
Oh,
right?
okay.
Yeah. Right, so you cannot, if you don't forget to delete first, you cannot simply just, okay, it's 10 already and 10. So it says 7 cannot be operated using existing sequence number. The current statement must be deleted. So that means this one must be deleted by no 10. If you want to delete 20, no 20, right? Then you can re-add it back 10, use the same sequence number 10, so that it is in the first location. Sometimes your ACE entry is not affected by the sequence, but sometimes the sequence does affect your final filter, right? So as much as possible, just follow your original sequence lah, right? Right. So here is an example of modifying when you're using a name ACL. As you show access list, it shows you this no access. The name ACL is no access. It shows you again the sequence 10 and 20, right? So you want to go inside your access list for your router. So IP access list standard, no access. Then you can create others, but so standard is now no access, right? So and then you want to insert. This one is insert. You see there's a range of 10 to 20 here. So in between is 15. So what you want to what you do is if you enter 15 the sequence, it will insert this between 10 and 20. So 15 deny this host, right? This host. Again, there is no wildcard for host. No need. Then when you show access list, you can see deny is inserted there, right? So now you have you can deny two hosts, one with 5, one with 10, right? And this one, the whole network range address. Right, so ACL statistics, it shows you statistics for each statement that has been matched. This one, since the time you bring up the interface and the access list been entered there, it keeps a sort of a not log lah, right? Sometimes you call it log lah, but we log the number of time that particular ACE actually is matched, right? So let's say deny ACE has been matched 20 times and permit ACE matched 64 times. So it will show that, right? Show access list once it's in operation already, and once the matching happen, it will start to keep track. Okay, you keep tracks of the matches, right? So 20 matches here means there are 20 instances where this filter, this one match, right? In this case, the second ACE, there are 64 matches, right? So the implied deny means after this 1020 is executed, we know, but we are not shown there is another default case, which is the deny all or deny any. Now, deny any will not be shown and will not be therefore you cannot see if there is any denied packets match for deny any, right? So if you want to keep track of that, you have to manually configure the deny any command so that it can be shown to you as part of the statistic, right? So let's say you don't want any more of these statistics. You want to reset it. Okay, you want to see because okay, now I want to see whether today is how. So I want to keep track of today. I already keep the history. So today I want to know reset from 0. So use clear access list counter to reset the statistics. So you start counting from 0 again. Right? Okay. So far, any question?
No.
No?
No.
No, huh? All right. Let's continue. All right. So this section is where we want to secure a V2I port with a standard IP version 4 ACL. Right. So VTY, we know is a terminal. It's a way for us to remotely access a host. Can be a server, it can be a normal host, normal computer, right? As long as there's a terminal server at there, you can then use a terminal client to connect to it, and then it includes the normal unencrypted terminal and also the encrypted ones like SSH, right? So, but normally this is a terminal line. So we want to filter whether we want to deny or accept, permit VTI ports. Right. Okay, standard ACL can secure remote administrative access to a device using the VTY lines by implementing the following 2 steps. Create an ACL to identify which administrative hosts should be allowed remote access. Then apply the ACL to incoming traffic on the VTY lines. That means VTY means we are not doing it on the we are doing it on the VTY lines, right? The application of the ACL. ACL, you simply identify which host considered as administrative hosts. That means the network administrators, PC or laptop or whatever that have access, remote access to the device. All right. So this secure your device. Not simply anyone can go inside your device. Right. So let's see. This one demonstrate how to configure an ACL to filter VTY traffic. Right. Before that, we need to have a user or username admin secret class as usual. Right. So we want to have a access list name access for admin host. Right. So this ACL, again, remark, ACL secures incoming VTY line. So we want to permit admin hosts to access remotely. Right. So permit, let's say our admin is IP address is this, the host 192.168.10.10. Right. Permit this one and then deny any. Implicitly saying that, explicitly saying that deny all the rest. Okay, this one will be configured first. We allow this one, then we deny everything else. Then we exit. Right. So now we have this admin host name access, then list, and then we go to the line. So line port 0 to 4, login local, transport input telnet, access class will be admin host and incoming. Of course, it's incoming. Right? So let's try to verify. If we want to verify, we just use show access list. It should show you the standard IP access list, the name access list, and then the sequence 10 permit this one and deny any after that. Right? Very simple, huh? So because it's terminal, the VTY, then if even if you transport SSH, it will also be affected, right? It will also be affected. As long as any of the VTY lines is protected this way. Right. So next we look at how to configure extended. Just now we look at standard. Extended allow us greater flexibility because standard is based on source IPv4 address. We filter based on IP address. Here we go a bit further. What do we filter? What protocols do we filter? Right. So you can see here it says extended ACLs provide a greater degree of control because not only you filter based on the IP address, but you can also filter destination address. Just now was only on source, but now destination address as well. So you can filter if before you, let's say incoming, and then you can filter based on destination address, right? Then what do you want to filter? That means if it's match any of the protocol, then depending whether if it match, you want to deny or permit. Okay, right? So common protocols, you don't have to specify what port, right? Let's say IP, TCP, UDP. Then, or you can also provide more detail again. What port number? So when you reach to port number already, you can see that it's very similar functionality wise with firewall, because then you have very precise control over the filtering. Right, so we can create extended ACL again, very similar to standard, by using numbered or named as extended ACL. Okay, the syntax to do for numbered is this: access list number, global configuration. That means this one is at the global configuration config terminal, right? Or you can use name IP access list extended and then the name. So this is the additional one. Just put the extended keyword here, then it becomes a name extended ACL, right? Right, so let's look at the protocol options. Very simple. If you want your inside command line interface ready iOS, go to config terminal, let's type access list 100. Well, we pretend it's 100 numbered. Permit what? Then we see what protocols can be filtered. As you can see, the protocols, acronym are given at the side along with the description, full name. So remember, as ICMP, we know ICMP is used for ping, right? So we know ICMP stands for Internet Control Message Protocol. So if you block ICMP, means you cannot ping already, right? If you deny, okay. Okay, the highlighted yellow, the significance that this is a common one, right? IP is very general, any internet protocol. So using any internet protocol will be blocked. ICMP, any ping, any ping similar to ping that use ICMP. Ping use ICMP, so ping will be blocked. Ping application. So and then TCP UDP, this is very common, right? Okay, so we learn about TCP UDP in transport layer. So TCP will, when you block TCP, there's a whole range of TCP that could be blocked. But then you can specify which TCP by a fine-grained filtering by using the port number. Okay. Right, so selecting a protocol influence the port options. Many TCP port options are available as shown in the output, right? So you can see here the example is access list 100 is numbered ACL, permit TCP any, right? Or that means anywhere in your network equal what? Then TCP, there's a lot of application that use TCP. So if you use TCP, it will list out the TCP based application. So question mark or application protocol, right? As you can see, all these are application layer protocol. So you can further equal, if you say equal FTP, right? And then FTP will be blocked. The file transfer protocol. That means your FTP client and server will not work or will be blocked. If you put it deny. If you permit, then FTP will be permitted, for example, yeah? Right, so let's have a look at the configuration examples. All right. Okay, yes, external ACLs can filter on different port numbers and port name options. Let's look at the example here. Extended ACL 100 to filter HTTP traffic. HTTP works on TCP, right? And HTTP is known as www, World Wide Web. So you can see it's using the port name, www port name. We know the port is usually 80, but you can also use www, right? So sometimes we forget what is the specific port number, so we can use their name, right? It's their name. If you're not sure what's the name to use, question mark. So equal space question mark, and we'll pick from the list, right? So both of these equal because you can either use the name www, the equal part, www, or we know that HTTP, right, use port 80. www is also use port 80. So we can also directly use the port number, okay, rather than the name. Okay, they achieve the same thing, right? So that means this access list allow HTTP traffic into your network. Later we'll see how when we configure in or out, right? But this filters HTTP traffic, right? Okay, so what about SSH? SSH we know using port number 22. So if you want to configure for SSH, you can just use the SSH port number. If you want to use secure HTTP, HTTPS, which is running on port 443, then you can allow 443. Right? Just examples. You can, so that means you can also for emails, for FTP, for whatever protocol. Right? Okay, so another example.
Is that invalid number?
Sorry?
Is there a list for the number used? Like this number is for HTTP, this number is for...
Okay. So I don't think there is, but because these are well-known port numbers, so you can use any reference for well-known port numbers. We learn about it in FCN. Yeah, okay. A list of well-known port numbers. Okay, so if you're not sure what's the name, but you're not sure what's the name, so you question mark, the name comes out, you're not sure which name is that, then you can I mean, what, not name lah, I think this is more like their what do you call this, their acronym, right? So if you're not sure about the acronym, then you can just get a list of the well-known port number, right? Well-known port number, then you can substitute. But most of this, actually, by the name here is very standard already. It's well known, right? For example, NNTP for network server, network time right, server, and then POP3 is for retrieving email, SMTP sending email, syslog, gopher, finger, all this echo. So if you're not sure, you're not sure what this echo for, then you can well simply search for what is echo, right, or daytime or discard or all this, right? All right, so these two example, right, to permit traffic, SSH traffic and HTTPS traffic based on these two well-known port numbers for these two protocols, right? Then this is to create ACLs, ACE in the ACLs. Now apply. How do we apply? So just now we got example here, right? So to permit TCP for this network address. So from 1 to 254 lah, right? And then ini lah, right? And then equal to HTTP and also HTTPS. Then you go to the interface, cite your access group, which is 110, and for inbound, right? And then it will be configured, right? So for the examples, we'll use this topology. Again, ISP represent connection to internet, and here we have three routers. Router 1 connects to two LANs. Okay. Okay. Why is this one has so 192.168.11? This one 10.11, but there's something here that I think it'll be stack, so it's fixed. So I think instead of 11, it should be 192.168.20, because here consistently we have 192.168.30, so 10, 20, 30. So different network addresses. So I think this one is a typo, replaced by this, right? Okay, so note the interface also. Right? So if there's any ACL, it will be configured at interface, right? Right. So TCP established extended ACL. So TCP can perform basic stateful firewall services using TCP established keyword, right? So this established keyword enables inside traffic to exit the inside private network and permits returning reply traffic to enter the inside private network, right? So that means it knows that the traffic is within, right? So you can see the meaning here: inside traffic to exit inside private network and permit returning reply traffic enter the inside. So basically this or this. Okay, assuming that this is your inside private network. But you will disallow outside traffic, right? As you can see, TCP traffic generated by outside host and attempting to communicate with inside host is denied. So, example R1, right? So, inside traffic go into R1G00, returning traffic leave, go out R1G00. Okay. So TCP request from PC1 to outside public node is permitted. But TCP reply traffic returning from outside permitted, but TCP request denied from outside public network host is denied. So it can go out and like this, go out and come back. R1 allowed. But from here, going inside here and out, not allowed. So that means you cannot have your own TCP or whatever service here. You can access service from the internet, but internet cannot access service from your network. Okay, my understanding of this situation, right? So basically, that is normally how most internal network works. You want to allow your internal host to access services outside of your network. Basically, you want to access, let's say you want to access a web server outside, right? But if let's say you're inside, you run a web server and you want to allow, let's say, maybe your policy is you cannot have your web server inside your PC where outside from the internet can access. Then you can do that. You can set a filter to do that. Means any outside host trying to access your web server will be blocked. Okay, so this is stateful firewall services. Any question on this part?
No.
No.
Yeah.
No.
Right. Right. ACL 120 is configured to only permit returning web traffic to the inside host. The ACL is then applied. So that means returning, it can differentiate between returning and initiating. Okay, initiating will be blocked, returning will be allowed. Even though the traffic all coming in from internet. Because returning is you send a request, you go to internet, and then the reply come back, R1 will not block. But if it is initiating, that means from internet trying to go in, then the firewall will block. This is what it means here. So this is the configuration to do that. Example, right? Show access list. Command show the inside hosts are accessing the secure web resource from internet. So permit, right? Permit TCP, any equal www or HTTPS. Right? And then extended IP address list 120. This one is the established, means TCP. You remember the TCP connection? If the TCP connection is the established connection, means it's a reply. Right? So established connection, it allows to go in. But if your originating or initiating connection from outside is not established, it is trying to sync, right? So extended this part, the established part is the one that permit this allowed to go out, this allowed to go in back reply with the keyword established. You see there, acknowledge or reset, like lead set, belong to existing connection, right? So if it doesn't have this, what does it mean? It means it was initiated from outside. It has not made connection yet. It's trying to make connection to a host inside your network. So that's why you can block it. Is that okay? This one, you have to recall back the three-way handshake for TCP. Do you remember that in FCN?
Yeah.
Three-way handshake to initiate TCP connection. Once three-way handshake established, then you have established connection. That's why it says established here. Yeah, let me just TCP three-way handshake. Yeah, this one. So let me just show you this. This one, three-way handshaking or TCP to establish connection. Once the three-way handshaking is achieved, then it's established. The what do you call that? Is let me see. This one goes here. Establish. Can you see that?
Oh yeah.
Ah, yes.
Okay, yeah. So the established here is the one, right? So the initiating is coming from client, which is inside your network. So it's allowed to go out, reply is established, allowed to go in. But if the initiating from outside trying to go in is just starting to connect, it's a early part of the three-way handshake, so it's not allowed. That is what we mean by stateful filtering. It knows the state of the traffic. Name extended IPv4 ACL syntax now compared to numbered. Okay, naming ACL is preferred actually because it's easier to understand. It's like a built-in documentation for you because, well, unless you don't name it using a meaningful name, but usually when we say we want to name an ACL, we will use a meaningful name. Right, so to use to create a name extended ACL, you can use this command IP access list extended. Keyword here is the extended. In this, because the other one not extended, then just IP access list and number list. So in the example, a name extended ACL called no FTP access. Immediately you know by the name that you want to disallow FTP traffic. So no FTP access is created and the prompt changed to name extended ACL. Name extended ACL. Extended name ACL, sorry. Right, so the way we read this one is extended name ACL configuration mode. Right, and then you can start entering the A statement here. Right. Okay, first create first. Okay, like typing this IP access list extended mode active access, then you will be entered into the extended name ACL, and then you can start entering your S here. Right. Right. So let's look at this example. Again, we use this topology. We have a router connected to the internet using this interface G1 and then G0 into our private network here. Okay, and we have a LAN address of this, right? This is our inside our private network. This is outside. This is internet public network. Right. So now I introduced to you two keywords, right? Surfing and browsing. Right. So the name itself not very clear, but we try to make sense of it by looking at the description, right? So when we use surfing as part of the keyword, we are doing this, yeah. We are permitting inside HTTP and HTTPS traffic to exit to the internet. Okay, our web traffic lah. Okay, surfing, web traffic can go out to internet, right? And then browsing will allow or permit only returning web traffic. Just now this condition earlier that we have created the established, but this one is using name, right? So we permit browsing means we permit whatever, because if we access a server, web server out here in the internet, we expect a return reply. So return reply allowed, or if we put browsing, right? Whereas other traffic will be blocked. That means incoming traffic from internet, not as a reply to our request from inside our private network, will not be allowed. Right? Same scenario as before. So how do we configure that? Using name extended, right? So you need to put both surfing and both browsing, right? So IP access list extended surfing, Okay, remark permits inside HTTP and HTTPS traffic. So permit TCP, the whole range of our private network. Okay, any equal 80. HTTPS is 443, so we create the two A's. And then we exit. Right, excuse me, a couple of minutes. Right. So sorry for the interruption. So after you exit, you go back to global config. Right, in the global config, you create another name, ACL, which is browsing. So surfing is allow our traffic to go out. Okay, for both normal HTTP and HTTPS. Browsing allow return traffic to come in. So you can see remark is only permit returning HTTP and HTTPS traffic. So again, the keyword is establish. Right, establish permit TCP any into our local network, our private network, establish connection from the internet. And then you go to the specific interface. Here, our interface is this. Why here? Why not here? You guys know why here? Sorry, why not here? Why here? You can see here interface G0 rather than G1. What happens if we filter here?
Filter ACL.
No, I mean here, have a look here. We create the two A's here. Sorry, the two A's here and one A's here. But then we have to apply to which interface. So the example here chooses the G0 interface. My question is, why this interface? Why not this interface? Does it matter? This interface or this interface? You place the A's in, the ACL, here or here? What do you guys think?
Is it different result, sir?
If we, well, think about it. If we filter here, can we check the incoming traffic for their content?
No.
I think no.
Access the incoming. I mean, for the outgoing, right? Outgoing we can whatnot, but here by incoming. The inbound traffic will be processed here, right? So we filter here. Is it processed yet? No, kan?
Yeah, and it's not processed.
It's not processed, right? Okay. So we permit this one, right? We permit this one. That means traffic going out, we permit. But here we want to permit and we want to deny also. We only permit establish, right? And establish, we have to go all the way up to transport layer, isn't it?
Yes.
Yeah, check back last week's topic where we say, well, when we're using the extended, right? When we're using extended, where should we put the guidance is where should we put the extended filter? Right?
Destination.
As close as possible to destination.
Oh.
Right? So this is closer than this one. Right? So once we select, we go into the interface and then we apply the ACE. Okay, we apply both surfing and browsing. Okay, so for surfing, is inbound. Is inbound. Is going inside router. Right? For browsing, is outbound. Means the internet inbound here, but it's going to outbound here. So that's why we put in and out here. Right? And then to verify, we type show access list. Then we can see it. You can see what we have configured now. All right. Right. So further to the show access list command, right? We use that to verify our ACL statistics as well. Right. Okay. So it will show us. Well, here it's not shown now, but normally it will be shown at the site how many matching. Okay. For statistics, ACL statistics. All right. All right, so that was inserting. Now we want to check the editing to edit the extended ACL. That's where, let's say you want to make modification, right? Again, you can do very similar to the numbered one. You can use the text editor, right? And it's actually, for me, it's faster. You know, you can put in no and the name and then recreate it again. Okay, just copy paste. Right, so to make sure where, you know, although I know which specific sequence I want to, you know, edit, remove and replace, right? But if I use a text editor, I can simply just delete all, recreate, and it only works if I've saved, right? If I save the most recent version of my ACL inside a text file. So I can just open it with my text editor. I know, oh, this is the most current content. So I can just put a no for that particular name ACLs, and then I can just recreate. I don't have to type. I just copy paste. I modify the value, copy paste, and then it's fast. Copy paste is fast. But this only work if you systematically keep an up-to-date version of the ACLs. Mean to say, if you've entered the ACLs, then your copy inside your text file will be exactly an up-to-date version of the ACLs you entered. So if you make modification, again, you go back to your text file, you edit it, you press the no to delete the entire, just recreate it again. That's that's for me is fast. But you can, very specific, identify the particular A's in the sequence number, and then make your changes based on the sequence number. Right? Again, here example is you incorrectly put in 19, so rather than 192. So basically, do a no 10 inside your name ACL. This show you, right? You can see you go in, you go inside the extended name ACL by typing that, and then says because the 10 is the one that you want to modify, again, you delete and then you enter the correct one, right? Okay, this is very specific lah. Or you can just use the copy paste method, right? And then you change lah. You change instead of 19, which is a typo, you put 192. Okay, again, show access list to show the correct updated ACS or ACE. Sorry. Right. Now let's do another example. Right, another extended IPv4 ACL example. We want to have two name extended ACLs, permit PC1 and reply PC1. So we have we only allow PC1 basically to access the internet and deny other hosts. Okay, and then since we allow PC1 to go out, and then we allow returning traffic for PC1, the rest again we want to deny. So we only allow PC1 access to the internet, right? We allow PC1 access to the internet, but at the same time we deny the internet access to our private network. Okay, here we specifically only want PC1 hosts rather than all the hosts. Okay, let's try. Again, you're going to use the G0. So create the access list, name access list, IP access list extended. Permit PC1 is the name of our access list, and you go to extended name access list, put the remark in, right? Then here, not only we allow www, which is port 80 and 443, we also allow other TCP service like 20, 21, I think that's FTP, and then SSH, Telnet, DNS is 53, DNS, right? So we have to enter individual port. The port number represents the protocol that you allow, right? And then you only put here, right? You can see we identify the protocols we want, right? And then after we permit this, then we deny the rest. Okay, so we allow 10, deny the rest, the whole range, except 10. You see it is applying in sequence. When we allow 10, this one will be other apart from 10. Then exit, and then we create the reply. The reply, our remark is only permit returning traffic to PC1. So permit TCP any host from outside into our specific host. So this is the filter. The filter is this. That means we don't limit any host that the PC1 can contact on the internet. That's why it's any host. So any host can reply, whereby the host usually is the servers servers of these protocols. Any, but only if the reply is to a specific host, which is 1010. Established means reply only. That means connection initiating connection from internet will be blocked Only reply from 1010. but from any host on the internet. That means that allow our 1010 host to serve into any server out there in the internet, because we say any host can reply. But we limit only these services, these protocols for this 1010. And for the rest, we deny. Right? Then and then exit. Then we go to that interface G0, and then we apply both name ACL. And that's it. Okay, so to verify, again, show IP interface for that particular G0 interface, because that's where we have allowed to the access list. Then it shows us outgoing and inbound. Right, at G0, inbound will be from our own private network or permit PC1. And then outgoing means from the internet to outgoing into our private network, we apply reply PC1. And then, of course, we see what is applied on G01. Then we can look at the access list for both reply and permit. So that means you do this first, get these two names, then check these two names here. Show access list, and it shows you permit PC1, all the aces, and then reply PC1, the ace. Right? Okay, traffic must be generated to verify operation of ACL. What does it mean? Means you have to test any of this, right? And to see whether there's a match, you want to see the statistics, right? So in order to have a match, traffic must flow. That's why traffic must be generated. So for each one, if you want to see there's a match for www or port 80, then you have to open your browser, point to a server out there in the internet. If there's a reply, there will be a match. It will be logged. Then you can see that, oh yes, exactly, it works because there's a match and I receive the traffic. So to test this, you cannot use ping, because ping is a specific protocol. So if you want to test telnet, then you have to use telnet or application that can generate telnet traffic. FTP, then application that can generate FTP traffic. Then you need to connect to FTP server on the internet so that it can reply you FTP traffic. Then you can see the statistic match or not on that particular access list. Right? Finally, there is this, again, we can use show running config. Again, show running config show a lot of things. So you have to filter it by begin IP access list. Then you can see reduce summary. Okay, it shows you lah. Okay. Right. Okay, any questions from you guys?
No.
So
No.
yeah, so that was all about the configuration part, the syntax. All right. So syntax and a few examples of how we can make use of the commands, okay, to specify both number and name for standard, and both number and name access list for extended. Right? If you want a simple filter, then you use the standard ones lah. That one is just basically filter all traffic. You have no you cannot like fine tune your filtering, but you filter based on IP address and only source IP address. If you want more than that, you can filter based on destination. You can filter based on protocols or port numbers. You have to go for extended. Okay, both standard and extended ACLs. You can use two types of configuration method. You can use numbered ACLs or name ACLs. We also learn how to modify, if you make a mistake, how to modify. There are two methods. You use the delete all and redo everything. Means copy paste method lah. Okay, you basically save the commands that you use to generate, and then you use the same command to make changes, but you can just remove all and recreate again. It's quite fast also. Or you can do precise one, to use the sequence number to remove the entry and recreate the entry, the correct entry. All right. Okay, so that was a configuration method. So now I want to just show you guys, before we go for a break, I just want to talk about the tutorial. So tutorial, we've only reached tutorial 2 previously. I will continue marking, of course. But last week's tutorial is supposed to be this. Okay, I shared it already and I'll assign to you guys the network security concept. Okay, and then for both last week and this week, the ACL concept. If you look at ACL concept, let me open first. You can see here it says refer to T4 ACL workbook. There are two versions. One is the older 1.0 version, but I shared with you the newer 2.0 version is under here, this workbook. So this workbook is actually a workbook just like the FCN last time, the subnetting, right? It's very good if you have the time and you do all the exercise here, right? But part of our tutorial is actually doing the exercise. So for example, standard ACL, page 5. So let's have a look. It's assigned to Farah. So page 5 on the here lah, right? Here. So page 5 means Farah will do this. Okay, Farah. Okay. Then yeah. So then Noel, page 17. So page 17 again, based on this one, okay, based on the page number on the document itself, page 17. Let's see. Here. So Noel will do here wildcard mask problem. Now, of course, for the purpose of our tutorial, you can do just the part where you assign, but there's no stopping you if you also, right, go and do on your own. Like for example, Noel want to try the Ferris one, then you can just Noel, you can just go to the particular page and do it, right? But I will mark the fairer one so you can compare your answer. Okay, right? So I've assigned already. So when you look at the page, it refers to the workbook. Find the specific workbook and answer the question indicated, right? Again, you can find it here under workbook section. Okay, this one is a version 2 rather than version 1 or version 1.4. So it's the latest one, right? Okay, so but before you go for ACL concept, try to do the network security concept first, right? Okay, so from previous week, week 3. Okay. All right, so right now we go for a break. Okay, because we finished early today, it's going to be a slightly longer break. So I'll see you guys exactly. You can start earlier on. Okay, but we will go for a break until the start of our tutorial, which is 3 o'clock. You can start from 3 o'clock, or you can start earlier. Okay, anyway, I will be monitoring, right? Okay, so we'll use our tutorial meet. Okay, we'll use our tutorial meet and go for a break. You can start early or you can start at 3. We'll do tutorial 3 first, and then do tutorial 4. Tutorial 4 basically is part of the workbook. Right, guys? All right. So I'll see you in the next, in the other meet.
Okay.
Yes, Farah, that's correct. IPS is intrusion prevention system. Yeah, usually implemented using some form of machine learning, right? So it detects software will detect like abnormal system usage or abnormal traffic, right? And will predict or identify that as a intrusion, right? And then work to alert the security, the uh, the security personnel. Yeah. Right. So if you want to include any other answers, you can do so, right? Just provide the citation. Huh? Citation, that means where you get the answer from, right? Not necessarily just from our notes. Can be from anywhere, but just cite your resource. I mean, the sources you get from maybe a website, then you provide the link to the website. You can, yeah? Noel, for question 2, can you select which of the MCQ, multiple choice answer for the MCQ, multiple choice question? Is it A, B, C, or D? Yeah. Right. Noel, just a comment. What about B and C? since malware is malicious software, so malware basically is malicious software. Okay, combination of malicious and software. So malware, malicious software. Right? So what do you think? Can B and C also be part of a malicious software? Yes. So it's D, yeah. And for question 3, Calvin, right? So you have to a little bit generalize your answer. Malicious software, yes, it can be. Malicious software can be a malware that is installed inside the private network, and it could be sending information out, and thereby the traffic from inside your LAN could be carrying some information that you want to keep within your network. So apart from that, for malicious software, to be honest, is the correct one is the network traffic, right? Because firewall blocks ports, right? Ports means the process. We identify process or programs that are network capable by identifying the port, because in order to communicate to outside, programs need port numbers. So if you block port numbers, means the program cannot then communicate, right? So maybe malicious software is correct, but maybe malicious software, right, that is network capable, right? Because malicious software tend to be keylogger, for example, right? So it logs your key, password, all this, and then send it over to the internet. So a firewall can be like a barrier to stop that from happening, right? So just a little bit more information about malicious software. So again, malicious software is malware, and it can send out information, right? So firewall can block. So firewall works both ways. It can block incoming traffic. It can also block outgoing traffic, right? So by blocking port number, then you effectively prohibit any software to connect remotely, whether from inside your private network to outside, or from outside to connect into another program inside your private network. Noel, can you provide a little brief description of what is data integrity, authentication, data confidentiality, and data non-repudiation? Just a brief description of each.
Okay.
Okay, so Farah's answer for IPS is correct. Blocking known attacks across the network, especially those attacks that exploits a common or well-known exploit tool, especially when there's a time gap between exploit is revealed and when you have time or chance to patch your system, right? Okay, because sometimes we call the exploit when it's released, first time release, a 0-day attack, right? So 0-day attack is we have to quickly, well, the security infosecs, information security people, they need to find out how to block that attack or what to do, right? So they will basically, for example, any um, antivirus software. Usually, we normally install antivirus software, but nowadays it's a whole suite. Okay, one part of it is antivirus, but one part of it is especially with Windows. It's called a Windows Defender now, right? It's also has a feature, IPS feature inside. So the moment the 0-day attack is detected, they will work against time to come up with a to not only to detect but to protect. So they will, example for software like utilities or tools or built into OS, they will release a patch, okay, that's work to block, right? So the IPS part of their I won't say antivirus because antivirus is very specific to virus. So for example, the security system or security software will be to detect. So they will update the IPS to detect those latest exploit and hopefully uh, do some patching. Yeah, do some patching on their OS. The especially those vulnerabilities that was exploited by that new or 0-day attack. Right. So Ferris is correct. Right, 4 elements of secure communication. Data integrity refers to accuracy, completeness, and consistency of data. So correct. Now, how do we ensure that? We ensure that um, by implementing some sort of checksum or some kind of function that can detect if the message or if the data has been how to say been tampered with lah, right? So it works by detecting any changes from the original data with the current data. If there's any changes, it will be detected, right? So just a comment to add on to that for data integrity, right? Authentication is basically to identify, a user, right? So the only authorized user will be allowed, right? I think authentication, the 4 elements, I think it's origin authentication. Yeah? Is it not? We have to authenticate the origin of the data. So for origin authentication, therefore, we want to guarantee that the data has not been tampered in the midst of being transmitted, right? So we want to make sure that the data the user receive is actually the actual data that was communicated in the first place, right? So guarantee the message is not a forgery and does not come and does come from where it's supposed to be coming from, right? So example, we using hash message authentication code or hashMAC to ensure there's no tampering. So if there's tampering, then it will be detected. Okay, the third one is correct. Data integrity. Let me just correct that. Yeah, that. Oops, sorry. Correct. That's correct. Data confidentiality. Data should not be disclosed to third parties. In fact, we're talking about data confidentiality, of course, cannot be disclosed. Actually, not third parties. It should be to unauthorized users lah. That's third party, because we still don't know whether the third party is allowed access or not. So let's give that kind of answer. Guarantees that only authorized users can read the message. Third parties is not so clear. Is a third party authorized or unauthorized? So you can say third parties, but you can say authorized third parties. So data confidentiality is implemented using symmetric and asymmetric encryption algorithm, right? So symmetric encryption means you encrypt using a key, and using the key you can decrypt it back. That's symmetric encryption. So ensuring the data is confidential because it's transformed. So symmetric using a key means you get the original data, you encrypt it, so it becomes encrypted data. So now people cannot view it without the key. To view it, they need to use the same key to provide the decryption, get back the original data. Okay, the most secure one is asymmetric encryption algorithm, right? So asymmetric encryption algorithm make use of public and private key, right? So anyone can use the public key to encrypt, but only the person who has the private key can decrypt. And actually, the asymmetric encryption algorithm is the more common nowadays, right? Harder to defeat or harder to break. All right, so I'll let you do first, Noel, for the last part, data non-repudiation. I go to Calvin Shah, difference in asymmetric and symmetric encryption. Right. Okay, so this is what I was talking earlier. The use of the different way, the process of encrypting and decrypting, right? So symmetric encryption using the same key to encrypt and decrypt data, right? That means you use the key to encrypt, because the function to encrypt takes the key as a parameter, and the key is used to as a seed to encrypt the data. So in order to decrypt, that means it can go the other way as well. To decrypt back, you need the same key and the key as a parameter to function to decrypt the encrypted data back to the plain text. All right, so that's correct. Now asymmetric means you need to use two separate keys. To encrypt it, you publish the public key to everyone. Everyone can have the public key. They use the public key to encrypt the message or the data. Okay, but to decrypt, they cannot use the public key. Okay, you cannot use the public key to decrypt. You need to use a different key, and normally it's a private key, right, to decrypt the information. Right, so that's correct as well. Okay, so the second type is more secure, and it also solves the problem. You know, there's a problem last time, right? How can, the thing is, someone in Russia wanted to send a box. Inside the box there's some or whatever information or jewelry or whatever. But the thing is, they cannot trust the people carrying the box. Want to maybe send the box to someone in France. So they lock the box with a key. The thing is, when they lock the box with a key, once the box reached France, the intended recipient cannot open because they have no key. But if they pass the key together with the box, anybody can get access to the key and unlock the box. So The thing is, two separate key. One key to lock it and another key to unlock it. So even if anybody got the original key that locks the box, they cannot use the same key to unlock the box. They have to use a different key to unlock. And only the recipient will have the private key. Okay. Right, we go to 7A, compare and contrast two social engineering attacks. Phishing and spear phishing. All right, so phishing is, okay, let Farah do first. Okay, and also Noel also still in the middle of doing also. So, okay, I'll let you guys fill up first. Answer. So I go back to question number 5. I think Noel has finished question number 5. Data non-repudiation. So what does this mean? According to Noel, allows a user that made any changes to data to have proof that they really did the changes. Okay, so that's basically what it is, right? The thing is, once the user make a changes, right, we can identify for a fact, okay, there's no ambiguity that yes, that is a sender, and that sender only had make the changes or updated the data or inserted the data or whatever, or transmitted the data, right? So that means it works both ways. So the user that made the changes also cannot repudiate, cannot say, I didn't make the changes, right? It works both ways. Not only that the user have a proof that we also have proof that the user cannot say he didn't make the changes, right? Okay. They cannot repudiate the fact that, oh, you are the one to make the changes and say, oh, no, not me. But, okay, I have proof to say that, well, maybe there is a way to tie that person that make the changes to the change data, right? So I'm just going to add some comments there. So example for data non-repudiation is, let's say I have a PDF, and let's say I need to sign the document digitally, right? So there is a security technique where you use digital signature. Now, it's not simply just inserting image of your signature, right? But it's actually using, even if you use a signature, a real signature, and then you paste it, but the image is treated in such a way that there's a digital component of that image signature that uniquely identify that this signature, this digital signature, really comes from that person. Correct? So usually, if in a document management system, there is such kind of thing where you will be able to use really certified, and digital signature that has a feature that uniquely identify the user that made that signature. All right. So maybe embedded inside the signature is an encrypted key or something like that anybody else who doesn't have it will not be able to say that oh, this is my signature, but okay, hang on, your signature, even though it's look identical, but it's not certified, right? So that's example is from the digital signature, right? So just I'll just give you what I got from this one. Just provide some comment. Oh, sorry. Oops, sorry. Use different font. Just to provide some extra info, and then I'll just give the link for you to read. Okay, so example lah, right? Okay, this is just an example where the data is because it's signed using a digital signature, then you cannot repudiate that document is basically, or that data is basically the origin is from that person. Right, so let me see. The next one is from Farah. Okay, still doing. Okay, never mind. No, also still doing. Okay, so let you guys do first. Right, so you guys done all Farah and Noel?
Oh, yeah.
I think I done.
Okay, so let me have a look. Yeah, Farah's chose phishing and spear phishing. Right, so although they have phishing in the names, they're actually two separate methods. So phishing, mostly by email and text message, that enters victims' curiosity or fear, which led them to links sensitive information. Clicking on links to malicious website or link attachment can contain malware. One example of phishing scam is victim receiving an email from online services telling them that their account is at high risk, then clicking on the link to protect their account for safety measure. So it's pretending to be a legitimate, right? Okay, so I just comment. In this case, um, fraudulent. So it's a fraudulent email, right? Fraudulent means a fake email, which is disguised as a legitimate, pretending to be a legitimate email. Right? Okay, that's correct. spear phishing. This is more targeted at specific. So spear phishing, phishing comes from the fishing, right? So when you fish, whichever fish will bite. So it's very generic, right? When you fish, when you do fishing, you're not sure who will bite. So it's aimed more in general public, right? Okay, but
Should I add in the answer more general? Like
not especially, because you already say it's targeted here, right?
oh, okay.
Yeah, but we identify because of the spear phishing, right? PH is used because instead of fish, right? It's supposed to be fishing, F, right? But they use PH because of last time, people use during the time, the earlier time when people used to hack not only computer system but communication system, right? And they call it freaking, right? Or freaking is hacking into telecommunication system, right? Last time, during 60s, 70s, I believe even 80s. I remember last time there was this very popular way to freak the telecom, the phone that uses a coin, right? People know how to freak it so they get free calls. Because of this PH, freak as freak, right? So PH is retained in the vocabulary for hacking. So they use PH here in terms of phishing, become phishing, and then spear phishing, because spear phishing, you identify the fish that you want to catch. So you spear fish, you identify and you basically target that fish. So spear phishing in terms of scams is a targeted version. So that's correct here, it's targeted, right? Okay, so it's targeted at specific individuals or organization. So more effort, because in order to target, then you have to find out more information is needed, right? So that it works better. And this actually is much better, right? Just like marketing, when you do a blanket advertisement, you don't know you will catch the customer, who will become your customer because of the generic way you do the advertising. Usually you put advertising on TV, put on a banner, all this kind of general marketing. But targeted marketing is more effective because you know the customer, what they want. So you push the product that is matched with that customer, right? So same with general scams, you basically based on probability lah, right? If you send it to 100 people, out of the 100 people, how many people will actually fall to that scam via email, right? So it's like a spamming kind of thing lah. But spear phishing, you're targeting the particular user or particular organization. So in order to make it work, you have to do a bit more. Just like the targeted marketing, you need to collect information about the user to find out what the user likes. So for spear phishing to work also, you want to target the organization, you want to target the user, specific user, so you have to know a little bit more about them. So that's why it requires more effort, right? Okay, so example, an attacker impersonating organizing IT consultant, which then emails one. Yeah, this is correct, right? So example also, pretending to be someone from your bank. Okay, so in order for it to work, they must know whether you do your business with that bank first. You have a account with that bank, right? Then it will work. Because if you're not, let's say they say, oh, I'm from public bank, but hey, hang on, I don't have public bank account. Why should public bank call me? So it doesn't work, right? So to target you, they must know first. you have an account with public bank, then I will pretend I'm from public bank, right? And then you have a credit card account, then I have to know whether you do have a credit account with public bank so that I can do a credit card scam with you from public bank. Okay, so this example where it's more targeted and it's more believable because it's more targeted, right? Nowadays, the scam involving Nigerian prince doesn't work because nobody actually can actually believe that there's a Nigerian prince that's going to give you money, right? Because in the first place, I don't know, you don't know any Nigerian prince or such thing lah, because it's too generic, right? But if it was something that really tie you up with it's more believable because let's say, like I said, a bank account, you have an account with public bank, you have a credit card account with them, so it's more believable to if they come and say to you that, oh, it's compromised, can you check something, can you email me something, then it's more believable, so it is more likely to succeed. Spear phishing, eh? All right, well, let's have a look at the novels. Two social engineering attacks are phishing and pretexting. Right, so pretexting. All right, so phishing first, often click on links. So this is the same as above, right? Right, clicks on the link. So the gap here, according to Noel, we can say that there was no antivirus or anti-malware security system or software installed in the user's computer. And that will be a security gap. Because usually if you have a security software installed in your computer, right? If someone click the link and the link actually execute a script, right? If it's something that the security software can identify, right? Then it will stop it from, or it will simply stop you from, in general, block that software or that link from going somewhere else. Okay, to do some harmful thing. So the security system will prevent in that way. So if we don't install, then there is a security gap, and it will work because no security software will block whether redirection to a site, phishing site, or malware infested site, or simply run the script that will activate malware. Right? Okay. And pretexting, the threat actor gains unauthorized access to the network and directly communicates to the victim, pretending as an authorized user by requesting confidential data. This convinces the victim they are communicating with authorized user. Okay, for pretext, the keyword is pretext. It means trying to pretend to be someone that you're not. So again, like you can imagine that it's like you can imagine that the attacker will use pretext. A pretext basically is a fabricated of a fake scenario, right? A scenario that a lot of people actually fall for, right? Like the Macau scam and all this thing. Okay, but that one involve financial, but not for the purpose of attacking your system, your computer system, but it is based on the same concept, right? So I'm just gonna give a definition here. Is this correct? Answer is correct. I just want to provide further info. Let me just reduce the font. Okay, it's from I just get it from this something's on the internet. Right. So key here is a good pretext or good story lah. Fake story, fabricated scenario, right? Okay, so any question about the or anything that you want to ask before we move on from this tutorial? I think we covered all already, yeah.
No question.
No question, huh?
No.
All right. So we have only 10 minutes left. So that's not enough to, you know, to go on. But you can do this as homework, tutorial 4, and we can discuss this in our next tutorial. Right. So a lot of this is actually coming from your workbook. In the workbook itself, if you open it up, right, now you can use if you want to do other exercises inside here, go ahead as homework, right? If you let's say we finish this one already, the tutorial, and as part of the revision, you still want to do other questions inside this workbook, feel free to do that. You can use any PDF editor to digitally enter your answer inside here as well. But not only that it has question here, but it also have information, right? Information about the access list. You can see here says what are access control list, general access list. So it's good for revision. Yeah? How routers use access lists, what are standard access lists, why standard access lists are placed close to destination. And then after talking about that, it talks about extended access lists, why ACLs are placed close to source, right? And so on. Some exercises, right? So again, some info here, choosing to filter incoming or outgoing packets, breakdown of a standard ACL statement, right? So you can see from here, yeah, it's a good way to, you know, to learn in more depth about access lists, right? Choices for using wildcard masks to match specific hosts, to match entire subnet, or to match specific range, or match all addresses. So here the examples are given, right? So if you encounter any kind of question where the policy, right? Maybe first policy or the second policy is needed, then you can view here as the example how to do the wildcard mask, right? So in this workbook, not only you have the questions, but you also have a lot of useful information as your reference, right? And for the question itself, they normally give you 1 or 2 examples how to answer, okay, so that you can proceed with the rest of the question, right? You can see here, advanced wildcard mask problem, right, and so on, right? Okay, so very similar to the workbook that you have done on subnetting earlier on. All right, so please continue to do the tutorial 4, okay, as your homework, right? And then we'll discuss in our next tutorial session.
Okay.
All right, everyone. All right, so thank you very much for today.
Thank you, sir.
I'll see you guys
Okay,
tomorrow.
sir.
Practical, yeah?
Thank you, sir.
All right.